The aims of this video will be to revisit multiplication in the context of a one-to-many relationship. We'll solve multiplication problems involving groups of 9. We'll explore strategies that will help us solve these problems more efficiently until we just know the answers. And these strategies will still be useful in the future, as they can be used to solve other more complex problems. You've hopefully explored other one-to-many relationships in other videos. Here we're going to look at 1-to-9 relationships. This pack of glue sticks shows this type of relationship because it's one pack but 9 glue sticks, so 1-to-9. 9 seems like it might be an awkward number when it comes to multiplication, but it can be quite simple if you connect it to things you already know well. Many people find multiplication problems involving groups of 10 quite easy compared to other groups. 9 happens to be quite close to 10, so we could use this to help us. We can imagine adding 1 more to each group when we're solving problems involving 9. Let's imagine a teacher was trying to work out how many glue sticks were left in the resource cupboard. She saw that there were 7 packs of glue sticks left. And remember, we know that there are 9 glue sticks per pack, so we're trying to calculate 7 groups of 9, or 7 times 9. Before you start, estimate how many glue sticks there are altogether. Remember, an estimate will give us a rough idea of the answer. It won't be exact, but it will be close, so we can use it to check if our final answer seems right. You might have thought about what we said before, about 9 being close to 10. So what if we worked out 7 times 10 instead of 7 times 9? 7 times 10 equals 70, so we know that there will be approximately 70 glue sticks, but not quite that amount. Pause the video before working out the exact answer to 7 groups of 9 before continuing. We can actually use our estimate to help us finish off this problem. Let's look at what 7 groups of 10 would look like. As part of our estimate, we imagined adding 1 more glue stick to each group of 9 to turn them into a group of 10, which is easier to work with. We know 7 times 10 equals 70. The amount we added was 7 lots of 1 glue stick, or 7 times 1, which equals 7. So 7 times 10 equals 70, and now we need to subtract the 7 groups of 1 we added. So 70 minus 7 equals 63. So altogether there are 63 glue sticks. 7 times 9 equals 63. What if you were trying to work out 9 groups of 9? How many glue sticks are there now? Pause the video and try to work it out before carrying on. Here's one way you might have solved it. Compare your strategy to the one here, thinking about any advantages or disadvantages. If I add 1 more glue stick to each group of 9, this will be easier to solve and will give me 9 groups of 10 instead of 9 groups of 9. I know that 9 times 10 equals 90. The extra glue sticks that I added can be represented as 9 groups of 1, or 9 times 1, which equals 9. To work out 9 times 9, I therefore need to subtract 9 from 90. 90 minus 9 equals 81. So 9 times 9 equals 81. There are 81 glue sticks altogether. Let's try one final example. What if you had 15 groups of 9? How would you solve that? Remember, think about things that you already know and see if you can use that to help you figure out an efficient way to solve this problem. One strategy you might have used, which is a little different from what we've done so far, is to see that 15 groups of 9 could be split into 10 groups of 9 and 5 groups of 9. I know that 10 times 9 equals 90, and 5 times 9 equals 45. I know that 15 times 9 is the combination of these two groupings, so I need to add 90 and 45, which equals 135. So 15 times 9 equals 135. So to summarise, we've revisited multiplication in the context of a one-to-many relationship. Here we looked at 1-to-9 relationships. We solved multiplication problems involving groups of 9. And we started to explore strategies to solve these problems more efficiently using facts we already know. At some point we'll just know the answers to these types of problems, but the strategies can still be used to solve more complex problems that we might come across in the future.